We're going to talk a lot about determining limits graphically, and the thing you have to understand the most is that when the limit of x as it approaches c from the left equals the limit as x approaches c from the right, then that equals the limit as x approaches c. It's really, really important that you understand that if the limit from the left and the limit from the right are not equal, then the limit does not exist. That's what we have to get out of this whole thing. So let me see. I know there's a spotlight feature here somewhere. Where is that? Tools? Spotlight. There it is. Oh boy, I didn't mean for that to happen. Let's get out of that. Okay. So we want to know the limit as x approaches 0.5. So first we're going to go from the left. So we start our pencil over on the left and we trace the graph. And we see that as x gets closer and closer to 0.5, the answer is 1.5. So the limit as x approaches 0.5 from the left is 1.5. And from the left we use a little minus sign there. Then the limit as x approaches 0.5 from the right means we start on the right and we start tracing the graph and we get closer and closer and closer to 1.5. So therefore, the limit as x approaches 0.5, since it's equal from the left and from the right, it is 1.5. Now here, the limit as x approaches 0.5 from the left is 1.5, and as x approaches 0.5 from the right, it's also 1.5. Just because f of 0.5 does not equal 1.5, that doesn't change the fact that the limit from the left and the limit from the right are equal. So therefore, the limit as x approaches 0.5 equals 1.5. Determine the one-sided limits. So that means we have to do the limit as x approaches 1 from the left, the limit as x approaches 1 from the right, the limit as x approaches 2 from the left, the limit as x approaches 2 from the right, the limit as x approaches 4 from the left, and the limit as x approaches 4 from the right. So let's start with 1 from the left. So we start at the left, we go until x gets closer and closer and closer to 1. It looks like we're getting closer and closer and closer to 3. The limit as x approaches 1 from the right. We trace the graph from the right, and it looks like as x gets closer to 1, the graph approaches 1. So if the question said, what is the limit as x approaches 1? The answer would be the limit does not exist because those are not the same. All right, 2. From the left, it appears to be 2. From the right, it appears to be 1. So again, the limit as x approaches 2 does not exist. 4. From the left, it appears to be 2. From the right, it's also 2. So the limit as x approaches 4 is 2. Limit as x approaches 1 from the left. So we start at the left and we go. Looks like it's 3. The limit as x approaches 1 from the right. Start over here. Trace. Still 3. So therefore, the limit as x approaches 1 equals 3. Let's try 3. Limit as x approaches 3 from the left. Start at the left. As x approaches 3, from the left, it appears that it's negative infinity. Like as x gets closer and closer and closer to 3, the graph keeps going down. So negative infinity. From the right, trace. From the right, it appears to be 4. So therefore, the limit as x approaches 3 does not exist. Let's try 5 and 6. I'm not going to write these down, I'm just going to talk about them. The limit as x approaches 5 from the left. So start over here, get closer and closer and closer to 5. The limit as x approaches 5 from the left is 2. as x approaches 5 from the right is negative 3. 6, as x approaches 6 from the left, is infinity. As x approaches 6 from the right is infinity. So the limit as x approaches 6 is infinity. All right, so we're looking at this graph for all these questions. As x approaches negative 1 from the right, that's 1. Yes, that's true. X approaches 0 from the left is 0. That's true. X approaches 0 from the left. Well, that's obviously false. It can't be two different things. 0 from the left and 0 from the right. So 0 from the left is 0. 0 from the right is 0. So yes, those are the same. True. So yes, it exists. Remember, if the limit from the left equals the limit from the right, then the limit exists. And the limit as x approaches 0 is 0. True. Therefore, this can't be true. As x approaches 1 equals 1. Now this is an interesting case because there's only a left-hand limit as x approaches 1. There's no, oh, I lied, there's a graph down here. So, as x approaches 1 from the left is 1. As x approaches 1 from the right is 0. So therefore, the limit does not exist, so that's false. This is also false. The limit as x approaches 1 does not exist. 2 from the left is 0. So that's false. The limit as x approaches negative 1 from the left does not exist. That's true. There's no graph over here, so there's nothing. But this would be a case where the limit as x approaches negative 1 just in general does exist, and it's 1 because there's only one side. So normally the rule is if the limit from the left equals the limit from the right, then the limit exists. But if there's only one limit, then whatever that limit is the limit of the number. All right, and the limit as x approaches 2 from the right equals 0. Same thing. This does not exist because there is no graph as x approaches 2 from the right. So it doesn't equal anything. It just does not exist.